section 3, we're looking at, I want you to be able to recognize if a series is geometric fit. That's the first goal. The second goal is, can you write the explicit formula that will generate terms of the geometric series? And then the third thing is, can you find the sum of the series? Now, some of them are easy. Some of them are definitely more complicated. So we're going to start off by just taking a look at these two examples, 1 and 2, and see if you can figure out what comes next. Just look at the pattern. Just take a second to look at both of them and see if you can describe in words how to get to the next term. Still looking for my calculator here. Somebody borrowed it and it hasn't been returned. Yeah, let's do it. Example 1. That's fine.
All right.
The next one would be 320, and how are we generating the terms?
It's just multiply by 2.
Okay, so each term is twice the previous term. 2 times 40, 2 times 80, so 2 times 160 will generate 320. All right. Allie, how you doing? Is everything okay? Are you sick or? Now, do we need to be concerned? Like, okay. Can you tell me what comes next here? What was it? What did you say? 1/5 is correct. I don't know. 1/5? I don't know. What? Absolutely, you know. If we went like this, it would have been easier, right? To see what comes next. If I said, what comes after the 25? That would have been easier. You've got to be versatile and be able to work with the fractions. I will tell you that in all of these sequences, decimals are really not your friends. Anytime you get a sequence of decimals, change into fractions, it'll be easier to follow. Absolutely. A lot of people don't take my advice. It's fine. Go with the decimals. I hadn't even sucked air back in from the sentence. Change decimals to fractions, and I'm like, I'm about to breathe in, and it's okay to use decimals, right? Are you listening? Yeah. So it's like, screw you, I'm doing decimals. Are you kidding me? Yeah, whatever. All right, so we're looking at these sequences. Sorry, this one you're multiplying by 2. This one you're dividing by 5. Just like with the arithmetics where I said stay away from subtraction, stay away from division. Change division to multiplication. So dividing by 5 is the same as multiplying by 1 over 5. 1 over 5, 1 over 5. So the next term would be 1 over 25. Or 0.04, excuse me. Those of you who like decimals, good luck with that. Here's the thing. Don't use decimals. But I will, of course, accept decimal answers. All right, so geometric sequences, here's the deal. You're looking for a sequence, a sub 1, a sub 2, a sub 3, a sub 4, where the ratio of any term to the previous term is constant. So when you look at the ratio of any term, the second term compared to the first term, the fifth term compared to the fourth, the 78th term compared to the 77th, whatever term you pick divided by the previous term, that's got to be the same number every single time. That's called your common ratio. We use R for the common ratio, and it's any term, a sub n, divided by its previous term, a sub n minus 1. Again, I would always reduce that ratio, and I would keep it as a fraction. Not for Nick. Nick's going to have decimals. But the rest of us probably want to write the ratio as a fraction. Just make sure it's a reduced fraction. It'll all be good. Okay, so we're looking at any term where you're multiplying one term by the same thing to get the next term. What am I multiplying by here? 2. 2 times 3 is 6. 2 times 6 is 12. 2 times 12 is 24, and so forth. The common ratio, R, can be found by taking any term divided by the previous term. So 12 divided by 6, 24 divided by 12, 6 divided by 3. They are all equal to 2. Okay. Geometric sequences are harder to work with than arithmetic. Okay, they're a little clunkier, for lack of a better term. But this ratio deal is what's important. Anyone know this show? It is a black and white. This show is an old show. It's from gosh, early 60s. This is Andy Griffith's show. This kid right here is Ron Howard. Okay, Ron Howard used to be an actor, and then he became a pretty well-known director. Most of you probably know his directorial stuff. Okay, this is from that TV show.
Well, if it ain't Charlie Moneybags, the big philanthropist. Not his sister.
What you talking about, Paul?
I'm talking about the underprivileged children's drive.
Oh, they collected for that at school, Paul.
Oh, I know they did. Oh, I know they did. And when they called your name, you gave the large, generous amount of 3 cents. My, that's big of you, Diamond Chin.
Did I give them too much, Paul? I could ask them to give back 2 cents.
Look here. We better talk about this thing. Now, look here, Opie. You can't give a little bitty piddling amount like 3 cents to a worthy cause like the underprivileged children's drive. I was reading here just the other day where there's somewhere like 400 needy boys in this county alone, or 1.5 boys per square mile.
There is?
It sure is.
I never seen one, Paul.
Never seen one what?
A half boy.
Well, it's not really a half a boy. It's a ratio.
Horatio who?
Not whole ratio, a ratio. It's mathematics, arithmetic. Look now, Opie, just forget that part of it. Forget the part about the half boy.
It's pretty hard to forget a thing like that, Paul.
Well, try.
What a Horatio.
Now, look, Horatio is not the only needy boy. Son, didn't you ever give anybody anything just for the pleasure of it? Give something you didn't want anything in return for.
Sure, just yesterday I gave my friend Jimmy something.
Now, that's fine. What'd you get him?
A sock in the head.
I meant charity.
I didn't charge him nothing.
I meant something for the joy of giving.
I enjoyed it. I don't like Jimmy no more. He makes fun of Charlotte,
Who's Charlotte?
my girlfriend.
Well, I just don't see how anybody who has got as much as you could care so little about others.
I care about others honest.
Not when you give a little piddling amount like 3 cents. That's being selfish. You should have given at least a half a dollar or a dollar.
$1? Gosh, Paul, I only had $2.20 in my whole piggy bank, and I'm saving it to buy Charlotte something.
Well, now that's dandy. That is just dandy. Whole dollars you'll squander on your girlfriend Charlotte, but when it comes to the underprivileged children's fund, you've got only 3 cents.
I wasn't going to squander it, Paul. I wasn't going to squander it.
Yeah.
What's squandered?
Throwing your money away foolishly.
Oh, but Paul, I wouldn't be throwing it away.
All I can say is if your head can be turned by a pretty face at your age, heaven help you when you're grown up.
All right, so there's your ratio. Really? It's probably better for me. Yeah. So, take a look at these sequences. What's the first question you need to ask yourself? Is it geometric? Please do not go down this path and expect that you can just say, oh, it's geometric, it's not geometric. you need to determine whether or not it's geometric. And you can do that by saying, am I multiplying by the same thing? You can even say, am I dividing by the same thing? And as long as the answer is yes, you can say, okay, it's geometric. But how you determine R has to be with the formula. Pick a term, divide it by the previous term, and find that ratio. So go ahead and try these. All right, let's take a look at example 3 here, the pink one. Robin, what do you think? Geometric or not?
Yeah.
Yes, it's geometric. And R was equal to 1 over 3. Okay, did you use the 1 and the 3 to get that, or did you use something different? Like, did you take this divided by this? Michaela, how about the second one, or example 4? Geometric? Why not? So it's not geometric. Is it arithmetic? Thank God this is being recorded, because you could go back and play that back to hear what I hear. Not very convincing. Raphael, is this arithmetic?
Yeah.
It is. What's the common difference?
Common difference.
Negative 2. How'd you get that?
Well, minusing
You minusing 2 each time?
times each.
We're doing example number 4, right?
Yeah.
What color is example number 4?
I'm colorblind.
There's 3 examples. Do you agree with that?
Yeah.
Which example, top, middle, or bottom, do you think we're working on?
Probably not.
The middle one. And you think we're multiplying by negative something?
No.
We're adding negative something.
Yeah.
What are we adding? Look at me. Look at me. What are we adding?
1.
I just want to know what we're adding. I want to know how you got from the first term to the second term. That would be, you said it's arithmetic, and I want to know what the common difference is. Is she your attorney? Look at me. Is this an arithmetic sequence? It is. What are you adding to get from one term to the next? That's called the common difference. Again, going to the attorney. Raphael, you're killing me here. Really? Yeah, me too. I'm really tired too. Can you tell me the first term in the sequence? What is it? Can you tell me the second term in the sequence? My question to you is, how much do you add to the first term to get to the second one? You don't need to ask anybody that question. Good. Can you tell me what the second term is? In the third term? And what do you add to get from the second to the third? Is this an arithmetic sequence?
Yes.
They're laughing because in arithmetic sequence you have to add the same thing over and over and over again. You want to go with a different answer to arithmetic?
Yes.
Not arithmetic. And what about you? No, you said, no. That's what you said.
I'm tired.
Yeah, we're going to do 2 together right there. That's perfect. So this one's not geometric, it's not arithmetic, and that was really painful. Oh. Allie, how about this one? Geometric, not geometric?
I was a little confused on the pattern with this one.
Okay, how do you go from here to here? If it's geometric, it has to be multiplication, right? What would you multiply this by to get this? Right. What do you multiply this by to get this? And again, when you get confused, and sometimes and if they're fractions, it gets even worse. When you get confused, go to your fundamentals. Is this true? Are they all equal to the same thing?
Yes.
Yes, and that something is? No, yeah, I mean, what is R equal to?
Oh,
Again, this, I'm not trying to trick you. R equals this.
okay.
Okay, nobody talks like that. Like, let's say it wasn't
Oh.
negative.
Negative 6?
Right. Always reduce, make it simple.
Okay.
You're trying to make this complicated right now, I can tell just by looking at you. You're just keep it simple. Any of these terms divided by the previous term.
Okay.
That's R. As long as it's the same every time, then we can say, you bet, this is geometric. All right? This sequence here is not geometric, it's not arithmetic, it's neither. It's not, here's what you need to know, it's not arithmetic, it's not geometric, it's neither. Of course there's a pattern. I just don't care what it is. Okay? Here we go. Just 3. What's 3 times 81? Okay, let's do an easier one. What's 3 times 3? Is that 9? Then this is not. R, again, go back to your fundamentals. 27 over 81. 9 over 27. 3 over 9. 1 over 3. Okay, in America, we're going to read these from left to right. Now, does anyone speak Arabic? Arabic, you read from right to left. So for him, he's all confused right now. Because he's thinking this is 3. Right? And this one should have been -1/2. It's really confusing. Okay, but we're going to go from left to right. Okay? Just for future. All right. So now let's take a look at this sequence, and let's break it apart the way we did yesterday. So a sub 1 is 3. And how do I get to a sub 2? Multiply the 3, bless you, by 2. And that's going to give me 6. How do I get to a sub 3? Multiply a sub 2 by 2. So we're going to have 3 times 2 times 2, or 3 times 2 squared. How do I get to a sub 4? I'm going to multiply a sub 3 by 2, which is going to give me 3 times 2 to the third, which is going to give me 24. What's this? Thank you. Where would we be without you, Josh? Ladies and gentlemen, this is a number. It's true. It's also blue and now shaded yellow, highlighted yellow. But what is the 3 in the sequence? A sub 1 is your first term. What is this 2 representing?
Ratio change.
Not common difference, not D. What was it? The common ratio. How do you find it? You take any term and divide the previous term. Now, the big deal is then we need to recognize this is 2 to the 0, this is 2 to the 1, 2 to the second, 2 to the third, and what you want to figure out is, how does this power relate to the position? How does the power in the position relate? Dorothy? It's 1 less than the position. So each of these powers is 1 less than the position that we're talking about. So somewhere here I should have a formula for you. The first term, the common ratio to the power of 1 less than the position, which would be n minus 1. And again, this is going to be what we call the explicit formula for geometric series or sequences. A sub n is any term will equal the first term times the common ratio raised to the power of 1 less than the position, n minus 1. So it works in the same manner as the explicit arithmetic, but obviously this isn't a plus minus deal, so we have to use the power, or we don't have to use the power, we just do use the power. Makes it easier. So take a second, there's 2 examples of geometric series here, or sequences, and I want you to write the simplified rule for a sub n. Your answer is going to be a sub n is equal to, and then you're going to plug and play for what. All right, Julia, how about A? What did you write for a sub n is equal to?
4 times 5 raised to n minus 1.
Girl. And you cannot multiply the 4 and the 5. Okay, that 4 and the 5 cannot be multiplied. For example, right here, this one is 3, first term 3, common ratio 2 to the n minus 1 power. A very common mistake is to make that 6 to the n minus 1. You can't do that. Order of operations says you have to do exponents before you multiply, not multiply before you do exponents. Okay? On the second example, Ashley, how about that one? What did you get for a sub n?
I haven't finished it. Wait, what?
Wait, what, where?
I haven't finished it.
That's okay, I'll wait, or we can do it together. It's
Okay.
not really very complicated.
Okay.
What should a sub n is going to equal
152.
152 times,
1 over negative 2.
all right, let's just go with negative a half.
Okay, and then raised to 7 minus 1. Oh, n minus 1.
N minus 1. If you wanted a sub 7, then you would plug in the 7. This is just asking for the rule. Okay? Write a rule for the nth term. That's this. That's this.
Why? Because I know for each term we're dividing by negative 2.
Okay?
So why difference between them all?
Okay, again, if we go back to the basics, I'm a fundamentals guy. So if we go back here, R, the common ratio, is found by taking any term and dividing by the previous term. Okay? Now, geometric sequences are not found generated by division. They are always generated by multiplication. Okay? Even though you can look at it and say, of course I'm dividing. So let's get to the example here. I'm dividing by negative 2. Dividing by negative 2, dividing by negative 2. I agree with that. But geometric sequences have to be multiplication. So you take any term divided by the previous term. That's where the negative 1/2 comes from. Okay? Multiplying by negative a half is the same as dividing by negative 2. You're absolutely right. How do I find the 7th term here, Ben? Plug in the 7. Did you do that? What did you get? 62,500. How'd you do that so fast? Good boy. And so you pull out your calculator. If you do it correctly, you just enter this and it gives you the answer. Okay. Dominic, how about this one? What was ace of 7 here?
So for the next one, the negative 19.
It would be, but I don't care. I don't want to know what the fifth term is. I want, yes.
So would we do a 7 goes to
152, parentheses, negative 1 over 2, parentheses, to the parentheses 7 minus 1. You could just type a 6. Positive or negative?
or no, negative.
I think it's positive. Negative 1/2 to an even power is going to be a positive. Times 152, 2.375. Okay? Which is perfectly fine if you're getting that out of a calculator. What you have to be careful of is I do not want a rounded answer. Do not round an answer and expect full credit. You won't get it. All right? If you have to, you change it to a fraction. Most of your calculators will do that for you. Any questions on either of these? Ben?
I think
It's not.
positive. If you type in negative 1.36,
That's calculator input error. That's operator error. If you want to raise it to a power, you need to make sure it's in parentheses. Because what you're doing, I'll just do it with a simple problem like this, Ben. You're doing this, and the answer to that is negative 4. But what we want you to do is this. And the answer to this is positive 4. So you know, or hopefully you know, 7 minus 1 is 6, right? Even power. Negative to an even, it's got to give you a positive. Now what you have is a pretty smart calculator. You got to put that thing in parentheses to raise it to the power. Okay, and the more complicated R gets, the more important it'll be that you have it in parentheses when it's negative. Everybody good on A and B here? I just want to write the rule for this. Okay, I want the rule, in other words, my answer is going to be A sub n equals. Okay, what is it that we're missing to write the rule? The ratio. So we know the first term is 1. We don't know what the ratio is to the n minus 1 power. If you can't find the ratio, and you wrote that down, that's pretty good. That's half the credit for me. That means this person has a pulse. Leaving it blank, not very good. How can I figure out what R is? Solve for R. So let's just put an R here, and let's plug in what we know. What could I put in for A sub n? Is there a term we know? 1 over 125. That's the fourth term. What could I put in for R? I have no idea. What should I put in for N?
4 minus 1.
But what should I put in for N?
4.
4. Now, here's my promise to you, and you need to pay attention to this because otherwise we could make this nasty, but here's my promise. This is 1 over 125 is equal to R to the power of 3, right? My promise to you is I guarantee that if you're having R to the third, then this right here is a perfect cube. I guarantee it will work out. Arthur? 1 over 5 equal to R. Matt, what's the A sub n formula going to be then?
Go up a little higher for it. It'd be 1
1.
plus R1, and then it'd be 1 over 5.
1 over 5. What are those two things doing? So I'm going to put that in parentheses.
And then
Minus 1, very good. There's always going to be a little temptation to put something in like a 4 for n. Don't do it. Because then you're looking at a specific term that you're finding, the fourth term. We want it to be generic. We just call it A sub. You don't need the 1 there. Right? I'm perfectly fine with you writing A sub n equals 1/5 to the n minus 1. You know what Nick's going to write though, right? Yeah, he's going to write A sub n equals 0.2 to the n minus 1 power, which I'm perfectly fine with. Yeah, don't you dug the hole, you need to sleep in it now. Everybody good? Okay. So we talked about this. Be careful of order of operations and don't multiply. Somebody in here is going to do that. It's a careless mistake. Try not to. Write down. Be careful. Don't do that. And that might help you. Okay, so one of your terms in the geometric sequence is 12, and it's actually the fourth term. The common ratio is 2. Write a rule for the nth term. What is it that we don't know this time? The first term. Now, I'm going to show you 2 ways to do this. I don't really care which way you do this, but if this was A sub 40 is 12. The first way that I show you is probably not the best way to go. What you're looking at is blank, 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 12. And R is 2. What's the next term after the 12? 24, right? So if you just use a little common sense, if you're multiplying by 2 to get the next term, what do you do to get the previous term? Yeah, so what's here?
6, 3, 1.5. 1.5.
You can come sit over right here next to Nick. Put all the decimal folks right there. Once you have this, it's all good. Now, again, if you have the 40th term to begin with, that's going to be a little more challenging. So the way that you're going to do that is to say 12 is equal to the unknown A sub 1 times 2 to the 4 minus 1 power in this case. So if you want the algebra for this, you're going to have 12 equals A sub 1 times 2 to the third. What's 2 to the third? That's your 8. And when you divide 12 over 8, will give you A sub 1, and A sub 1 when you reduce to 3/2. I don't need you to do that if it's a small number, but honestly, if you try to play this game all the way through, you're going to have issues. Okay? So if this is true now, let's see what's the rule going to be for A sub n. Why are we going with the 1? Why are we using 1? Okay. Do you have the general formula written down somewhere? The explicit formula for geometric sequences? So what should I put? 3 over 2 times. That wasn't hanging out your tail. It's, yeah, you do. You have it written right there. A sub 1 times R. What's R? 2 to the Emma, that's going to be 3 over 2 times 2 is 3, right? Remember 2 times 2 is not 3? You don't multiply these two together. Okay, you have to do the power, then do the multiplying. Don't fall for that trick. Remember yesterday? Yes, sir?
When you're doing that, could you also say students 3 divided by 2 times 2 to the n minus 1? Could you also do a to n equals 2 times n 3 times 2 raised to n minus 2 power?
No.
Because dividing, when you're raising 2 to any
This
power.
is what I want you to do.
Okay.
Okay? If this is a 5, that doesn't work, right?
Right.
We're not going there. A sub 1, r, and minus 1. Okay? This is Mr. Rogers. Okay? And this is Trolley Trolley that takes you to the land of make-believe. And I believe that's King Friday. I have to go back and look. It's been multiple times since I've seen this. So when you have a situation where they give you 2 terms in the sequence or the series, and they want you to either find a rule or find a certain term, you're going to use the land of make-believe. Now you can go look at what the book does. They have you use 2 variables and write a system of equations and solve. And it works great. Knock yourself out. For me, I would just set up the sequence. This is our sequence. And this is a geometric sequence. What are we going to do?
And negative 48 is a sub 1.
And then this would be a sub 4. So we're going to go to the land of make-believe and just pretend that negative 48 is your first term. Okay? And if that's true, we can plug in 3072 for a sub n is equal to negative 48 times the unknown r, that's our big problem, we don't know what r is, raised to the what power? 4 minus 1, or third power. I promise you, I swear on the book of Algebra 2, that these always will work out to nice, pretty integer problems. Okay? So when you divide 3072 by negative 48, what do you get? 2 or 64, thank you. Equals r to the third. 3072 divided by negative 48 is negative 64, and the cube root of 64 is 4. So the cube root of negative 64 is negative 4 for r. Now we don't know what a sub 1 is still. Okay? If this is negative 48 and r is negative 4, we would multiply to get to the next term. What do we do to get to the previous term?
Divide by negative 4.
And what would we get? 12. And what would be in the first spot? Negative 3. Is everyone following how I got the negative 3? It's not in the a sub n spot. It's in the fourth spot. We move Mr. Rogers here. We call this we pretend this is the first spot, so this will be pretend the fourth spot. I know this term, right?
Yeah.
Put it in for a sub n.
Okay.
What position is it? That means for n, put a 4.
Oh.
That way these two are always connected. Fourth position, fourth term.
Okay.
Okay? And then first position is a sub 1, the negative 48, but I don't know what r is.
Okay.
Lets me get r and get back to a sub 1 in the real world. So my a sub n formula is going to equal what, Riley?
A sub n equals negative 3 times
A sub 1 times r to the n minus 1 power. The tough part is going to be finding the pieces to plug in. And if you have to go to the land of make-believe, so be it. Nothing wrong with that. Everybody good so far? Let's talk about the sums. Now, get to the sums. The sum formulas, there are a lot of them for geometric sequences or series. And there's really multiple versions of the same formulas. Okay? So this is two formulas. I personally don't use the first one, but it works great. I use a different version of that, which I'll give you in a moment. You're best off having them all. Why would you want to sell yourself short? So this sum formula is the first term times the quotient of 1 minus r to the n over 1 minus r. And for these, r absolutely cannot be equal to 1. If it was, you would have an undefined sum. When r is equal to 1, we'll deal with that later. This formula requires you to know r, a sub 1, and n. So in order to use this formula completely, you need a sub 1, you need to know r, you need to know n. So it's all about what you're given. This formula is different. This is a sub 1 minus a sub n times r. Again, you have to multiply here first. It is the number one mistake made on the test for chapter 12. People will multiply or subtract a sub 1 minus a sub n, then times by r. Right, Michaela? It's a horrible mistake to make. Okay? Over 1 minus r. This time you need the first term, the last term, and the common ratio. First, last, common ratio. Over here, you only need the first, the common ratio, and how many. Saves you from going out and getting the last term to do extra work. Okay? Has everyone copied these two? Good? Everybody good? Okay, so here's another one. A sub 1 times 1 minus r to the n over 1 minus r. Is that one of the ones we have? Nope. So a sub 1 times 1 minus r to the n over 1 minus r. That's got to be this one. This one and this one are really multiple versions of each other. And if you distribute the a sub 1 into the parentheses, you get this one. So the first one I gave you, this one, and this one are all different versions of the same formula. And I honestly don't care which one you use, or if you use any of them. It doesn't matter. But those, the first one, this one, and this one, are all the same deal. And in each of those cases, you need a sub 1 or n. But they're all the same formula, just different presentations of it. Okay. I don't particularly like the first one, but it's out there. These two work great. Do it whichever way you want. Everybody get these copied? Okay. Hurry up, there's Michaela here. Got the head bobbing, all that going. I know you are. It's just so hard. Especially when you go to the land of make-believe, it's just so peaceful there. You feel so sleepy. Beatles and the Wizard of Oz. Cast a spell. Everybody good? Alright, so let's see if we can find a... So when you see the summation notations like this one, okay, you're finding the sum of a sequence. Now, the more you do, the better you're going to get at these. What's R in this sequence? 3. What's R in this sequence? 3 over 2. It's the thing being raised to the power. That's your common ratio. How do we find the first term from sigma notation? Plug in general. The bottom number. Plug in whatever's on the bottom. That will generate your first term. How do you find the last term? Plug in the top. How do you find how many terms? Plus 1. So 6 minus 1 is 5, plus 1 is 6. 16 minus 1 is 15, plus 1 is 16. When you start at 1, it's always the top number. Which formula you want to use, it really doesn't matter to me. But honestly, I'm going to use one of these versions more likely than I am any of the others. So I am probably going to go with S sub n is going to equal a sub 1 times 1 minus r to the n over 1 minus r. And all I need to know, the only thing I don't know is a sub 1. And again, that's very simple to find. You can almost do it in your head, most of you. 1 minus 1 in this case is 3 to the 0 times 4. A sub 1 is 4. 1 minus 3 to the what power? 16th power divided by 1 minus 3. Now sometimes when you do this, you get some pretty big numbers, but the big mistake that people make is they do 1 minus 3 is negative 2, and they raise it to the 16th power. You have to do 3 to the 16th. Subtract that from 1 and divide by negative 2, or times by 2.
I was just wondering, because don't you put 16 in for I?
Only if you want to know what the last term is. And you are more than welcome to do that and use this formula. Absolutely. So if you put in the 16 here, you have 3 to the 15 times 4, whatever that big QG number comes out to be, that would go right here. The first term, you would plug in the 1 right here and you'd get a 4. So 4 minus big QG number times 3 over 1 minus 3. That works great too. I didn't mean to force anybody to use my phone. But if you're using a multifunction calculator and you do it correctly, you can do this in one shot. You will need to make sure that the top is in parentheses like this and the bottom is in parentheses like that. And then you can just enter what you see and you'll get the correct answer. What is the sum going to be for this series? 92,000?
93. 440.
Okay. I don't expect anybody to have troubles entering into a calculator.
So, top.
All the way to the top?
Okay. I was,
All this thinking's out loud,
I
just,
thought a sub 1 was 1 because I did, I put I equals 1. So I did with 0. So I did 3 equals to the 0. So
which is 1, times by 4.
Yeah, okay.
Just forgot the 4. When your variable's in the power, it's going to be geometric. And when you're multiplying and adding and subtracting to the variable, and there's no powers, either variable powers or constant powers, you're looking at an arithmetic. Okay, that's a great question. I sometimes look at it and I go, oh crap, I'm not sure. And when you say I'm not sure if it's one or the other, what could you do? I usually just plug in a few numbers for I or N or whatever it is, and look at the pattern and say, is it arithmetic? Is it geometric? Okay? So when you really get stumped, just put in some consecutives of 1, 2, 3, or whatever the bottom number is, and, and then increase by 1 and increase by 2. Okay? So if you really get stuck on that, that's always a good way to go. We're not doing that problem. This is the other type of a sequence. Okay, take a look at that sequence, and what I want you to think about without saying it out loud is what kind of a sequence is it? Parker, what do you think? Dude, you the man. How could it be either?
It could be arithmetic and you're adding through it time.
Yep.
Or it could be
Absolutely. This is an arithmetic or a geometric. You're adding 0 or timesing by 1. It always boggles my mind that people have a problem with finding the sum of this sequence. What's the next term in the sequence? Yeah, we don't usually get too much trouble with that, but when I say find the sum of the first 9 terms, you can't believe how many times I get wrong answers for that. It blows my mind. Taylor, what's the sum of the first 9 terms of this sequence going to be? 27. How'd you get it? 3 times 9. You take whatever term repeats, multiply by how many you want, perfect. It's 27. So if you want a formula for that, boys and girls, here it is. Those of you who like recipes, here's your recipe. If you're looking at the sum of a geometric sequence where r is 1, okay, only when r is 1, take the first term and multiply it by how many terms in the sequence. This is one of those common sense deals. You don't really need to follow a formula, but if it makes you feel better, so be it. We had a test years ago where it was a no calculator test. I had a student who said, can I just leave the calculator on the corner of my desk? I won't use it. I just need the security of knowing it's there. If you need the security of the formula, fantastic. This is in the notes today. So this is the formula sheet for the arithmetic series going up and down here. We didn't do recursive formulas. You do those by instinct. So we're good at don't have to worry about those. So here's your explicit, here's your sum. And for geometric, here's your explicit, and here's 3 sum formulas if you need them. We'll talk about the infinite sequences tomorrow and why some of them have sums and some of them don't. Again, I want to stress the fact that the first question you have to ask yourself is what? What is the very first question you should be doing? Yes. What kind of a sequence is it? Is it geometric? Is it arithmetic? When you forget to do that, that will be when you make the mistakes. When you take for granted what you think might be arithmetic without checking it, I guarantee we will catch you. Okay? Is this sequence arithmetic or geometric? Arithmetic. What's D? 3. Is this sequence arithmetic or geometric? Geometric. What's R? That's the kind of thought process you want to have. And then plug into the formulas based on what you're looking for. Okay? This is the assignment that goes here. As far as I know, that's it. Maybe we have something different. Let's check. That's not. Hey, you need to make like some enthusiasm. You need. It's not. Oh. It's like doing. Yeah, it's the same. Hooray! That's what I'm talking about. See? It's all about your attitude.